So let me copy and paste this. So let's talk about how I find or how I use inverses now of matrices to solve a system of equations. Okay. Now, what I want to refresh your memory of is, let's just assume instead of a matrix equation, let's just assume I have a regular equation. Ax is equal to b. Normally, what you would do to isolate x is you would divide both sides by a, correct? Well, we can't necessarily divide a matrix by a matrix. So what do? So A is the coefficient matrix. X is my, variable matrix. X is your variable matrix. And B is your constant matrix. That's what they're called. And I'll show you what I mean. What we want to do is we want to find the inverse of matrix A. So x is equal to, it's very similar to dividing both sides by A. X is equal to the product of the inverse of A and B. This is my variable matrix, is equal to the product of the inverse of A and B. Very similar to dividing, right, by A. So obviously I need to be able to find the inverse of matrix A. If it doesn't exist, then I might not be able to solve this equation. So I want to look at this equation, this system of equations. And let's identify the coefficient matrix. So the coefficient matrix, and this is already in the proper form where my x's are lined up, my y's are lined up, my z's are lined up, my equal, and then my constants. So my coefficient matrix, I'm going to do my x column, my y column, and my z column. Okay, this is my coefficient matrix. It's the matrix that represents the coefficients of the variables to the left of the equal sign. My variable matrix are the variables involved in order, x, y, z. And then my constant matrix, right, are the constants to the right of my equal sign. Okay, now what I need to do here is, let's first find the inverse of matrix A. So x is equal to A inverse times B. So in order to multiply these two, I need A inverse. So let's focus there. And let's focus on finding the inverse of matrix A. Okay, so we already determined the inverse of matrix A using our calculator in the last video. So let's pull that back up. And we're going to go across the top. Row 1, 7 halves, 0, negative 3. Row 2, negative 1, 1, 0. Negative 1, 1, 0. Row 3, 0, negative 1, 1. 0, negative 1, 1. And this is the inverse of matrix A. And if you want to see that video, you could check it out. Okay, so now we have the inverse of matrix A. Double check, make sure that you copied everything down correctly. And let's copy down matrix B, which was our constant matrix from our equation that we're trying to solve. 8, 10, 9. 8, 10, 9. And okay, so we have everything we need. Now we can determine the actual solution. So our matrix A inverse times B is equal to row 1, fractions, yeah, but it's not too bad of a fraction because the denominator is 2, so as long as we multiply it by an even number, it'll simplify nicely. This is a 3 by 3 matrix, this is a 3 by 1 matrix, so we can do the multiplication. The two middle numbers are the same, and the outer numbers are 3 and 1, so our product is going to be a 3 by 1 matrix, 3 rows, 1 column. So let's go ahead, row 1, column 1. We're going to go across the top. 7 halves times 8. 8 times, or 8 divided by 2 is 4. 4 times 7 is 28. Plus 0 times 10. Plus negative 3 times 9. Minus 27. Negative 1 times 8. Row 2, column 1. Plus 10. Plus 0. 0. Minus 10. Plus 9. Simplify. 28 minus 27, 1, 2, and then negative 1. This is our solution to our system. So our matrix X, which contains, or is called the variable matrix, contains X, Y, and Z, our variables in order, is equal to 1, 2, negative 1, which means, right, again, this is matrix X. Don't confuse that with the variable X. It contains the variables in our system. So now we know that X is equal to 1, Y is equal to 2, and Z is equal to negative 1, and this is the solution to our system using inverse matrices.